Hey guys, today we are going to talk about one of our three legal moves, and that is zero pairs. So before we dive into zero pairs, I do want to go over the tiles really quick. So we have three different tiles, right? Oh, I guess it would help if you could see that, huh? Okay, so we have three different tiles. We have our ones tile right here, which is all those small little squares. I have an X tile. Remember X, I don't know how long it is. And then X squared, which is X times X, right? This should totally be a review for you. And if they're red, meaning the other side, that means that they are negative. Okay, so that's just a really quick refresher. So if you see this, it means 1. If you see this, it means x. And this is an x squared. So when we're talking about combining like terms, these are the three different kinds of terms that we could have. So what does this mean for zero pairs? Well, if I have a -1 and a +1, right? -1 plus 1 equals 0. Okay. Same thing is true with x's. Now, I don't know the value of x, but if you think about it, anything minus itself, what is that going to equal? 0. So any number minus itself will always equal 0. So it doesn't matter if it's a positive x and a negative x, or a positive x squared and a negative x squared. Either way, if they are the same tile, but one is positive and one is negative, they're always going to equal 0. Okay, now why does this matter? Why does this concept of 0 matter when we're trying to simplify expressions and solve equations? So if I had 9 and I add 0 to it, what does that equal? Well, that just still equals 9, right? Now, what if I have 9 plus 0 plus 0 plus 0? Well, we know that that's still going to equal 9, right? So I can add 0 as many times as I want without changing the value of what I started with. The same thing is true with subtraction. If I start with 9 and I take away 0, or take away a 0 pair, right? Together these make 0. So if I take away 0, that's still going to equal 9. All right, 9 minus 0 is 9. Minus 0 again is still 9. Minus 0 again, I still have 9. So I can add or subtract 0 as many times as I want, and it's not going to change the value of the expression. All right, so let's practice this a little bit with some tiles on a mat. So I have here, move this out of the way. I have here, I'm actually going to take some of these from our other page. Okay. So first, let's just try writing an expression for what I have here on my mat. Okay, so I see two x's. I see 1, 2, 3 negatives. So I can either say plus -3. Oh, you can't see that. Plus -3. Or we can say -3. Those are the same thing. Okay, I think some of you are getting confused on this. So for me, in my brain, it's easier if I see that these are red, if they're negative, I'm just going to subtract. All right, and then I see two positives, so plus 2, and then a negative x, so minus x. That's what I have up here on the top. So I'm going to rearrange my tiles so that I have the same terms next to each other. And what I mean by terms in this case is just the different tiles. Remember when we were talking about the different kinds of tiles, we said that each of these shapes represents a different type of term. Okay, so if I move my x's together and I move my ones together, now I can make 0 pairs. Remember, so right now with this 2x minus 3 plus 2 minus x, this equals a certain value. We don't know what it is, but it equals something, right? We don't know what x is, so it could be a lot of different things. But if I subtract 0 from whatever value that is it going to change the original value? No, because I'm taking away 0. And like we saw on that last page, I can subtract 0 over here. I can subtract 0 as many times as I want, and it doesn't change what I'm starting with. All right, so what other zeros can I get rid of here? So I see two sets of 0 pairs up here. -1 plus 1 equals 0. So I can take away that 0. I have another 0 pair up here of -1 and +1. So I can take those away too. Now, are there any other 0 pairs up here? Your answer should be no, because these are two different shapes. These are two different tiles, so they can't cancel each other out. So what am I left with on my mat? Well, I have x minus 1. Okay, so these two expressions would be equivalent. I did not change the value of the expression. I just regrouped it and made 0 pairs. Okay, so let's try this algebraically. So I mean with an expression and trying it, well, let's use tiles too. But so I'm going to use page 6A from our workbook. We're in the Unit 2 workbook, and I'm turning to page 6A. This one was homework, so hopefully you guys finished this one, even though we pretty much did all of them together as a class. Okay, so I'm just going to start with this number 1 right here. I have -3x minus 5 minus 4x. So thinking about this with the tiles, okay, I'm going to start with -3x. So here is 1, 2, 3, -3x. Those are red, which means that they're negative, minus 5. Now remember what I said when we were talking about our tiles. -3 is the same thing as adding 3 negatives, okay? So I'm going to put down 5 negative tiles. The -1 tiles, I should say. 1, 2, 3, 4, 5. Okay, and then I have more negative x's. I have -4x right here. So I'm going to add 4 more negative x's. Now my first step is just to regroup so that I can tell what I have. So I'm going to put my x's together because they are like terms, and I'm going to keep my 1's together because they are like terms. All right, so now I'm going to look for 0 pairs. Now I don't see any 0 pairs because there are no positives in this problem. They're all negatives. And I can't do matching sets. You got to be careful here. There is only one expression. I'm not comparing it to another expression. So remember, with matching sets, that's that math is fair, keeping it balanced. Whatever you do to one side, you have to be able to do to the other. In this case, there's only one side. It's only 1/2 of an equation. So we can't do any matching sets or anything like that. So I'm just going to put together what I have, which is 1, 2, 3, 4, 5, 6, 7 negative x's. So I'm going to write minus 7x. And then I have 5 negative tiles, -1s. So I'm going to write minus 5. Now that is as simple as you can get. So when I tell you to simplify an expression when it has x's in it, you're going to end up with something like this. Okay, let's look at number 2. So in this case, I don't see a sign in front of this 9 at all, which means that it is positive. So I'm starting with positive 9. 5, 6, 7, 8, 9. Now I have a negative x and another negative x. Then I am subtracting 10. Okay, now remember these tiles right here, they kind of look like x's, but they have those lines in them and they're longer than an x. So remember, this is 5 of our 1 unit square. So I'm going to use this because it'll be a lot easier to get to 10. Okay, so there's -5, and then I only have one of those, so we'll do 5, 6, 7, 8, 9, and 10. And then finally, I am adding 5 x's. I ran out of room, so I'm just going to put them down here. Okay, so I have 9 minus x again, minus 10 plus 5x. All right, so my first step is to combine these terms together. Okay, so I have these x's here, and I have all of those ones. So now looking at my 0 pairs, how many zeros do we see over here? So your answer should be 2 because I have 2 negative x's. That's all I have for negative. I have more positives, but I can't take away these x's because they don't equal 0. In this case, I do have 0 because any number minus itself is 0. So those can go away. Now over here, I see 5, 6, 7, 8, 9, 10 positives. 10 negatives and 9 positives. So how many 0 pairs am I going to be able to make? And your answer should be 9 because the smallest amount that I have is of the positives, which is 9. So there's 5 0 pairs right there. Then there's 6, 7, 8, and 9. And I have no more positive tiles, so I can't do anything with this one. I cannot make a 0 pair. Okay, so all of this went away. And what am I left with? Well, I have 3 positive x's and I have 1 negative 1 tile. So I can write plus negative 1, or we can just write minus 1. They both mean the same thing. Okay, so let's try one without using tiles. All right, let's look at one that's a little bit more complicated. Let's look at number 4. Okay, so thinking back to our tiles though, I have 6x squared, which means that I would have 6 of these positive. Okay, then I have negative 8x minus 2 plus 3x plus 4. So if I were to model this with tiles, how many different tiles would I need? You should be saying 3 because I will need an x squared, I'll need x's, and I will need 1's. I'm not worrying about the positive or negative right now. I'm just worrying about which tiles I need. These are going to be each type of term in this. So I see for x squareds, I just have this 6x. So this 6x is going to, 6x squared is going to stay by itself. All right, now looking at my x's, I see 8 negative x's and 3 positive x's. So in your head, you should be thinking 8 negatives and 3 positives. 3 of these are going to cancel each other out, and I'm only going to be left with negative 5x, right? So if I had 8 negatives, 1, 2, 3, 4, 5, 6, 7. I know I said I wasn't doing this with tiles, and now I am, but that's okay. 8 negative x's and 3 positive x's. I'm essentially subtracting these, right? So 3 of these will cancel out, and I'm left with negative 5x. Okay, now same thing, but now looking at those ones, the constants. Remember, constants don't change. Wow, this is a terrible highlighter. Look at that. Okay, so I have negative 2 and positive 4. So if I were to write that out as negative 2 plus 4, okay, you should end up with positive 2. So I have 6x squared by itself. For my x's, I said I have negative 8x plus 3x, which I just figured out means negative 5x. Okay, and that x squared is by itself. So I'm going to have 6x squared minus 5x plus 2. All right, now just let's do one more looking over here at number 5. So I'm not going to use any tiles this time. I will use the highlighter, but I'm not using any tiles. So first, I'm going to look at my y's. I have 2y and minus 4y. Okay, so 2y minus 4y is going to give me negative 2y. 2 minus 4 gives me negative 2. All right, looking at my x's. I have plus 7x and plus another x. So altogether, I have 8x. So I have negative 2y plus 8x. All right, and then finally, let's look at our x squareds. I keep using that pink one. Let's use green. Okay, so I have negative 3x squared, and then I have negative 2x squared. So negative 3x squared minus 2x squared, that's negative 3 minus 2, is going to give me negative 5x squared. And that's your final answer. Alrighty, guys, those are 0 pairs. Hopefully this clarified some things for you if you were a little bit confused. Please don't hesitate to ask any questions like always. All right, thanks, guys.